nothing happens, and it keeps not happening forever.
The universe, vast and mysterious, has fascinated humanity since time immemorial. From its birth in the Big Bang to its current expansive state, we have sought to understand not only its origin, but also its eventual destiny. Over centuries of observation, experimentation, and theoretical exploration, scientists have developed several compelling theories regarding the end of the universe. These theories span from scenarios of heat death and the Big Crunch to more esoteric ideas involving quantum fluctuations and cosmic inflation. In this video, we will explore these theories, contemplating the possible ways in which the universe might meet its end. Heat death, entropy's triumph. One of the most widely accepted theories about the fate of the universe is heat death, also known as the Big Freeze. This scenario hinges on the concept of entropy, which dictates that in a closed system, disorder tends to increase over time. In the context of the universe, this means that as the cosmos continues to expand, it also becomes increasingly disordered. In the early stages of the universe's expansion, matter coalesced into galaxies, stars, and planets due to gravitational attraction. Stars formed, burned through their fuel, and eventually died, some in spectacular supernovae that scattered heavy elements throughout the cosmos. Over unimaginable spans of time, however, stars will exhaust their fuel, and galaxies will drift apart beyond our reach due to the ever-accelerating expansion of space. As this process unfolds, the universe will gradually grow colder and darker. Stars will burn out, leaving only cold, dead remnants, like black holes and neutron stars scattered across a desolate expanse. Eventually, even these remnants will evaporate through processes like Hawking radiation, leaving behind nothing but an incredibly thin, cold soup of particles and radiation. This state, where the universe reaches maximum entropy and can no longer sustain processes that generate energy or maintain structure, is known as heat death. The Big Crunch, gravity's last stand. Contrary to the expansive vision of heat death is the idea of the Big Crunch, a scenario driven by the gravitational attraction of matter in the universe. According to this theory, if the expansion of the universe were to slow down and reverse due to the gravitational pull of all matter within it, the universe would eventually collapse back in on itself. In this scenario, galaxies would begin to move towards each other as space-time contracts. As the density of matter increases, temperatures would rise dramatically, leading to a cataclysmic collapse. The universe would end in a reverse of the Big Bang, compressing into a hot, dense state from which no structure could survive. This event, while dramatic and compelling, faces significant challenges from current observational data, suggesting that the universe's expansion is accelerating rather than decelerating. Vacuum decay, a sudden end. Moving into more speculative and exotic territory, there is the theory of vacuum decay. This idea arises from our understanding of quantum mechanics and the nature of fundamental forces in the universe. According to this theory, the universe as we know it exists in a stable state, but it may not be the only possible stable state. In some models of particle physics and cosmology, there exist different states of vacuum that could potentially be more stable than our current state. If the universe were to undergo a transition to one of these lower energy vacuum states, it could trigger a catastrophic chain reaction. This transition would propagate at the speed of light, rewriting the laws of physics as it goes. In such a scenario, life and structure as we know it would be instantly annihilated, with no warning and no possibility of escape. While this theory remains highly speculative, it highlights the fragile and contingent nature of our universe's stability. It reminds us that the laws of physics we observe today are not immutable, but rather a product of the specific conditions in which our universe finds itself. The Big Rip, torn apart by dark energy. Another unsettling possibility is the Big Rip, driven by dark energy, the mysterious force responsible for the universe's accelerating expansion. If dark energy continues to increase in strength over time or has a more fundamental role in the fabric of space-time than currently understood, it could lead to a dramatic escalation in the expansion rate of the universe. In the Big Rip scenario, the accelerating expansion would eventually become so powerful that it would overcome all gravitational and electromagnetic forces holding galaxies, stars, planets, and even atoms together. As a result, Everything in the universe would be torn apart at the most fundamental level, leading to a universe where even space-time itself would be shredded into nothingness. This theory is unsettling, not only because of its violent implications, but also because it suggests that the fabric of reality itself is subject to forces and dynamics that we have only begun to comprehend. Eternal inflation and multiverse, universes without end. Finally, there is the idea of eternal inflation and the multiverse. According to this theory, the Big Bang that created our universe was not a unique event, but rather one of countless such events occurring across an infinitely vast and continually expanding multiverse. In this framework, new universes are constantly being born from the chaotic inflationary process that characterizes the early moments of each universe's existence. Each universe may have its own physical laws and constants, leading to an unimaginably diverse array of possible realities. While individual universes within the multiverse may have their own beginnings and ends, the multiverse as a whole could be eternal, with new universes continually emerging, even as others reach their ultimate fates. This theory offers a profound shift in perspective, suggesting that our universe's destiny may be just one chapter in an infinite cosmic narrative. Conclusion. The fate of the universe is a topic that combines cutting-edge science with profound philosophical questions about existence, meaning, and the nature of reality itself. From the cold, entropic demise of heat death to the cataclysmic collapse of the Big Crunch, from the sudden annihilation of vacuum decay to the violent tearing of the Big Rip, and from the eternal proliferation of the multiverse, the universe's end presents a panorama of possibilities that challenge our understanding and imagination. While current observations and theories provide tantalizing glimpses into these possibilities, the ultimate fate of the universe remains uncertain. Perhaps as we continue to probe the cosmos and refine our understanding of fundamental physics, new theories will emerge that shed light on this enduring mystery. Until then, the exploration of the universe's fate continues to captivate and inspire generations of scientists, thinkers, and dreamers alike. In contemplating these theories, we are reminded of our place in the vast cosmic tapestry and the profound interconnectedness of all existence. As we gaze into the depths of space, we are also peering into the depths of time, confronting the limits of our knowledge and the boundless mysteries that still await discovery. As Carl Sagan once said, somewhere something incredible is waiting to be known. The ultimate fate of the universe may be the most incredible discovery of all,